we're having a look at the pH scale here, which is something you'll be familiar with from sort of year 7. And it's a very, very simple concept, but we're going to sort of go a little bit deeper. We're going to have a look at some quite complicated maths. You don't need to know the formulas, but you do need to kind of understand where they come from. So let's have a look. Now, this is what you'll be familiar with. This is a pH scale. It goes from 1 down here, so highly acidic, over to here, 14, so highly alkaline or basic. The difference between alkaline and a base, sometimes we sort of interchange the terms. A base will be solid normally, and alkali will be solution. All alkalis are bases. Not all bases are alkali. So if it is in solution, it is going to be, we tend to refer to it as an alkali. Once it is a solid, we would refer to it as a base, but we can still refer to alkalis as base because an alkali is a solution. And you'll probably be aware that pH 7 is neutral. And here's just some examples of products that items that would have those acidity. Now, what would be quite interesting to do is have a look at the pH of something like Ribena and have a look at the pH of Coke. Because actually most people think Coke is very, very acidic. Coke will be around here. Ribena is actually sort of down here. So those sort of squashes, the only reason is it's very dilute. So once you dilute it, it's no longer got quite the same concentration of hydrogen ions or protons, and therefore it's not quite as acidic and not as corrosive. Something to bear in mind is when we look at pH, the reason we have a capital H and little p is because actually what we're looking at here is the concentration of hydrogen ions, and the greater the concentration of hydrogen ions, the lower the pH, and that's done using a formula. And this is the formula that shows you how to calculate pH. You don't need to know this. You need to understand the basic concepts of it, right? So you've got something called a minus log. So this would be minus log 10, and this is the concentration of hydrogen ions. Because it's negative, what that means is the bigger that this number is, the lower this number is, right? It also means because of the log, that means an increase in 10 here will give you a change in 1 here. So if I make this 10 times more concentrated, this pH will go down by 1. So 10 times more, 1 less. And that's because of this formula here. If you go the other way around, just to invert it, to find the concentration, you would take 10 and then put it to the power of minus pH. You've got this in your calculator, so it's worth having a little play around with this and just putting in, making up some concentrations like 0.5, click minus log 10 of 0.5, see what the pH comes out with, and then multiply it by, or make it 10 times more dilute, and do minus log 10 of 0.05, and just see what effect that has on the pH, because what that should do is diluting it by half, so making it diluting it by 10, so making it 10 times less concentrated, you actually increase the pH by 1.